America has taken big steps to create a new energy future. We're generating renewable power all across the country and finding cleaner ways to use fossil fuels. Abundant supplies of these carbon-based fuels means they'll provide most of our energy for decades to come. But how can we use those resources and reduce the amount of carbon dioxide that's released into our skies? One answer is to capture carbon dioxide and store it underground, permanently and safely. The most efficient way to capture carbon dioxide starts with a process called gasification. Instead of burning fuel, gasification creates a chemical reaction that combines refinery waste, coal, forestry wastes, or even trash with oxygen and steam under high pressure to create a clean, pure gas. Gasification breaks everything down into molecules, so you can capture all the impurities and safely remove the CO2.
Well, the process of gasification actually makes the job of capturing the CO2 in the first place easier. And if it makes it easier, it ends up making it a bit cheaper as well.
We already use some of that captured CO2. For example, it's the key to enhanced oil recovery, where CO2 is pumped into poorly producing wells to recover the oil that's left underground.
At the plant here at the Great Plains Synfuels plant, we've been sequestering carbon dioxide since 2000. On a daily basis, we send to Canada about 150, 160 million cubic feet of carbon dioxide per day, and it's used in oil fields for enhanced oil recovery.
Using carbon dioxide for enhanced oil recovery helps us produce millions of barrels of oil. Scientists believe there's enough oil still trapped in mature oil fields to meet America's energy needs for the next 50 years. And CO2 captured through gasification can help do the job. But because carbon dioxide will continue to be a problem, scientists are testing techniques to permanently store it deep under the Earth's surface.
We use proven technologies that have been used for decades to find these storage sites. We have the technology that allows us to look into the Earth to find secure places to put it, and the monitoring technologies that allow us to verify that that CO2 remains in place safely.
To keep the CO2 locked underground, you need a rock reservoir of sandstone and shale.
You need to have the right package of rocks in order to be able to store carbon dioxide in the subsurface. So you need to have sedimentary rock that's porous, that has space between the grains that make up that rock, and then another rock on top of that, which essentially acts as a seal. So this is an example of what one of the shale seals looks like. What makes it a good seal is that it's essentially impermeable, so the water or CO2 trapped beneath it won't pass through it. The sandstone is made literally of lots of different grains of sand. So you can see that that water drop is actually going into those pore spaces. So what you're really looking for to safely store carbon dioxide is a package like this, where you have a rock beneath that actually has a pore space in it, and a rock on top which acts as that seal.
One of the first large-scale demonstration projects plans to compress 1 million tons of carbon dioxide and inject it 1.5 miles below the Earth's surface.
The success of a project like this is that we safely and effectively put into the ground the 1 million tons of carbon dioxide, that we can verify the performance of the reservoir, that is, the reservoir is not leaking, and carry out all the environmental monitoring and basically find no carbon dioxide.
Geologists have found extensive rock reservoirs here in the United States. In fact, there are enough of them to safely hold all the carbon dioxide from all our power plants for hundreds of years.
Carbon sequestration and storage is a viable technology. We need to demonstrate that there is no undue risk. This can be done safely and effectively, and it can be done with some degree of reliability.
Widespread carbon capture and storage won't happen overnight, but it will be essential to reducing CO2 emissions in a growing economy, and gasification will play a critical role in getting us there.
The gasification process makes it easier to capture the CO2. We actually can put the stuff in the ground and store it safely.
Visit gasification.org to learn more about how this clean energy technology will make carbon capture and storage part of our future.